In today's video I want to talk about power laws, and I want to start right away because it's a lot you have to remember about that and we don't want to waste any time. If you talk about powers, for example, if you say 7 to the power 4, what do you actually mean with that? So what you mean is you are multiplying first of all the 7 with itself. In this case the power defines how many times we are multiplying the 7 with itself. So in this case we are saying 7 to the power 4. What does that mean for us? It means we're multiplying 7 times 7 times 7 times 7. So 4 times the 7 multiplied with itself. And that's already it. So for the basis of what powers are. So the first rule is if you take something to the power of 0, that's always 1. So if you take 7 to the power 0, that will always be 1. If you take 5 to the power 0, this will always be 1. So no matter what, no matter how large the number is, it's always equal to 1. So remember that. Second rule, almost the same, and it should be pretty obvious, because if you take the power of 1 to something, this will always be the same as before. So just write down in a general form, x to the power of 1 will always be x. And we've seen it over here as well. So if we would have 7 to the power of 1, which we have in our example, you would stop here, so that means you won't multiply the 7 to anything else. Next rule, multiplications of powers. First of all, I want to talk about multiplications with the same base. So we are multiplying 7 to the power 3 times 7 to the power 4, which is nothing else than 7 to the power 3 plus 4. So what you need to remember is that you can technically write it this way as well. And the 7 to the power 3 times 7 to the power 4 is the same as 7 to the power of 7. Why is that the case? So you could technically split the 7 to the power 3 up and the 7 to the power 4, and you would have a very long multiplication. And what you see is now that if you would count all the 7s up, you would end up with 7 7s. So this always refers back to the main rule about the powers, and you will see that this is nothing else than 7 to the power 7. You can do the same with divisions as well, so this is why we have our next rule for. However, with divisions it's the other way around, because you subtract it. So if you have 7 to the power 5 divided by 7 to the power 3, you'll end up with 7 to the power 5 minus 3, which is the same as 7 squared. The explanation for this is basically because if you again split it up and write the whole multiplication down, you see that if you look at this fraction, you could cancel these 7's out and reduce the fraction, and you would end up with 7 times 7, which is again nothing else than 7 squared. Next rule, now a multiplication with different bases but with the same power. So we have 7 to the power 3 times 4 to the power 3. And this is technically almost the same as what we had before. So first of all, if you don't know or if you don't remember the rule, always write it down first and then rewrite it into the form you want to have it. So that means 7 to the power 3. This is how you would write the multiplication down, and this is for 4 to the power 3. So what you can do is now, if you think about it mathematically, you could just rearrange it and write down 7 times 4 times 7 times 4 times 7 times 4. Put everything into brackets, and now you'll see we have it once, twice, 3 times. And this is nothing else than what I already wrote down beforehand. So 7 to the power 3 times 4 to the power of 3 is nothing else than these two bases multiplied with each other, put into brackets, and to the power of 3. The next rule is basically the same. So now we have again the same powers but different bases. And what you need to remember about this is just basically that if you have the powers within each line of the fraction, you can just basically put the fraction itself into brackets and take to the power of what you had before. So we had power of 3 put 7 over 4 into brackets and take it to the power of 3 now. So you see that the roots split up on each other. 7th rule, so now we have the power of something to another power. What you need to remember is that, for example, if you have a case like 7 squared to the power of 5, this is nothing else than if you would multiply the powers. So what we did over here is then 7 to the power of 2 times 5. And how that is possible is basically, if you would again split it up, you would say that's basically 7 squared. 7 times 7 is 7 squared. Nothing new to you. And then you write it down 5 times. So 7. So you see, this is basically what we had over here. And if you count now all the 7s, you would definitely get 7 to the power of 10. Because we have 10 sevens. Next point, something which is very important, especially for derivatives, which you will work on later in school. 7 to the power of minus 5, so now we have a negative power. What you need to remember is that if you want to rewrite it, you would just put that into a fraction, and you would have 1 divided by 7 to the power of 5 now. So you see, what we did is basically we converted the negative power into a positive power. And as I already said, remember that because it's super important for derivatives later. And the last rule, which looks shocking at first sight, is something that you just need to learn by heart. It can be very, very useful and helpful as well, especially for rewriting when you work with derivatives, as I said before, for rule 8. But it's something you need just to learn by heart because it's rather uncommon. So what you're doing over here is basically you have something to the power of a fraction. So we have 7 to the power of 4 over 5. And if you want to rewrite it, you can rewrite it as a square root. So as a step-by-step guide, what you do first is you take your numerator and your base. So you write down, as what I did over here first, you write down the base 7 to the power of your numerator, and then you take the square root, or you take, in this case, the 5th root of 7 to the power of 4. Nothing else. To make it a bit easier for you, now I will show you a rather common example. So the square root of 25 is nothing else than 25 to the power of 1/2. And if you would again rewrite it, this is what the square root technically means. And this is what you're doing with the numerator, because you only have 1 in your numerator now. So you are saying 25 to the power of 1, and you're taking the square root of it. I hope you see that it's basically the same as what we did over here. Just that we have a bit more complicated case now. So again, numerator to the power of the base, put the root around it, and the degree of the root is then your denominator. And that's already it. Thank you guys for watching. I hope you enjoyed this video. Check out the other videos on my channel, and if you have any specific question or any specific mathematical problem, let me know in the comments down below, and I will make sure that I go through it and make a video about that.